Today we're exploring some terminology and some basic operations with polynomials. And so a polynomial, it says there, is just a sum or difference of a series of monomials. So that, of course, begs the question, what is a monomial? So a monomial is a term involving numbers and variables that has no addition or subtraction in it. So a monomial, mono meaning one, nomial meaning number, so together we take that to be one number. And even though there are multiple parts to 5xy squared, if we were to plug in values for x and y, we would eventually end up with just a single number as the outcome. As opposed to a binomial, bi meaning two, so n squared minus 25. So in that circumstance, we end up with two separate numbers that are connected by that subtraction symbol. Whatever we get for plugging in n and generating n squared, the number for n squared, and then 25. A trinomial is the only other type of expression that has a specific name besides the generic term polynomial. But you can see here we've got 1, 2, 3 separate terms. Now these are all polynomials. It's just that those that have 1, 2, or 3 terms in them have those specific names. But they're all still captured underneath the umbrella of polynomial, as is anything that has more terms than that. Now, when we talk about the degree of a polynomial, we have to look at the degree of the individual terms, at the individual monomials that make up that polynomial. So we're going to take a look at this 8x squared y squared first. And so the degree of that monomial is the sum of the exponents of all of the variables. So in this case, we can see an exponent of 2 on the x, we can see an exponent of 2 on the y, so the degree of that term is going to be 4. For this term right here, 3xy to the fifth, so don't forget that the exponent on the x is a 1, even though it's not written there. So if we add the exponents on the x and y, we get 1 plus 5 makes 6. And so then for the last one, there's just the y cubed, so the degree of that term is 3. So those are the degrees of all the individual terms of that polynomial. But when we want to say what is the degree of the overall polynomial, we're just going to take the largest individual degree. And so we would say that this is a 6th degree polynomial. Now, a polynomial is considered to be written in standard form when it's written in descending exponent order of the variables. Now, in the previous example, we had a mix of x's and y's, so in that case, it's a little bit more complicated about what rule we follow. You start off with the earliest alphabetical variable, and then you go in descending exponent order for it. But we're not going to see too many examples where we're going to have multiple variables and be asked to try to write that in standard form. Instead, generally speaking, we're going to see something like the first one, maybe something like the second one, where, like I said, we're going to go based off of the earliest alphabetical variable. But we have a couple operations in front of us here that we have to perform before we can put our answer into standard form at the finish. And so in this case, we've got two polynomials that we're subtracting, but in the case of the second one here, we have a negative 2, and it's a negative 2, that negative sign goes with it, that we have to distribute first. So the first set of parentheses here really mean nothing. So I've got 3x squared minus 12x plus 7. So I'm just going to write it without the parentheses. And now I'm going to distribute that negative 2 to the second set of parentheses. So negative 2 times negative 6x squared gives me positive 12x squared. Negative 2 times that positive 3x gives me a negative 6x. And then negative 2 times negative 1 gives me positive 2. And so now at this point, I just need to gather my like terms. So I'm going to combine the coefficients without changing the exponents. When you add and subtract, the exponent doesn't change, just the coefficient out in front changes. And I'm going to go ahead and do it in order of highest exponent down to lowest. So I've got a 3x squared and a positive 12x squared. So those are going to combine to make 15x squared. So that takes care of those. We'll cross those off just so they don't distract us. Then we've got a negative 12x and a negative 6x. So those are going to combine to make a negative 18x. Since they're both negative, we're going deeper into negative territory, so we get negative 18x. And then finally, we've got the, if I cross those out, we've got a plus 7 and a plus 2, so we combine those to make a plus 9. So by doing things in that order, we ensure that we've got our final answer written in standard form, which is generally the preferred practice when it comes to these types of polynomials. In the next one, it's just a straight distributive property question. There may be some combining of like terms at the end sometimes on these, but generally not. So I'm just going to distribute and follow my rules for multiplying these types of expressions that involve the exponent rules that we studied in a previous section. So for the first piece here, I've got 3 times 2 gives me 6. Then I've got a times a to the 4th, so that a here has a 1 exponent, so I'm going to add those exponents to make a to the 5th. Let's try to make that look like 5. Then we've got b squared times b to the 3rd, so we get b to the 5th as well. Then I'm going to distribute to the second piece in the parentheses, so I've got 3 times negative 7, so I get negative 21. Then I'm going to do the same thing with the variables. I'm going to add the exponents on the a's, add the exponents on the b's, so we get a to the 4th, b to the 4th, and then finally distribute to the last term inside the parentheses, so we're going to get negative 12 a to the 3rd, b to the 3rd. And now none of those are like terms because we don't have the exact same exponents on both the a and the b, so that is the best that we can do. And that one is written in standard form because we're going in order of the highest exponent on the a, even though they happen to be the same all the way through. We would focus on the a to make sure that we were in descending exponent order for that. Now in the last couple examples, we again are going to be multiplying some polynomials, but instead of having a situation like we had here, where we were just distributing a number into a set of parentheses, or over here where we had something a little bit more complicated that we were distributing, now we're multiplying a binomial times another binomial. And hopefully recall from our Algebra 1 days that this requires a technique called FOIL, which ensures that we make sure that everything in the first set of parentheses multiplies everything in the second set of parentheses. So FOIL is an acronym, the F standing for first, meaning I'm going to multiply the first term in each of the two binomials. So I've got x times 2x gives me 2x squared. Then I've got to multiply the outer, that's what the O stands for. So I'm going to multiply the outside terms. X times 1 gives me x. Then I'm going to multiply the inner. I stands for inner, so I'm going to multiply those two terms. So negative 4 times 2x gives me negative 8x. And then finally L stands for last, which is negative 4 times 1, so negative 4. And then the last thing I've got to do is I've got to combine my like terms. And so oftentimes by multiplying the binomials in this order means that the middle two terms will be where we'll find our like terms. So we've got 2x squared minus 7x, so plus x, so plus 1x minus 8x combines to make that minus 7x, and then the minus 4. And so that's the best that we can do with that expression. And as a bonus, if we have drawn out the lines for FOIL correctly, we have made Binomial Man. You're welcome. In our last example that we see in front of us, the FOIL principles still apply, even though we're eventually going to be multiplying a couple of terms that have more than just two pieces to them. So when we see x minus 3 cubed, first and foremost, exponents do not distribute. So we cannot take that 3 and just cube the individual pieces. If you want to do that, that's a sure way to get things very, very wrong very, very fast. So instead, what we have to do is recognize that that exponent is saying we are going to multiply x minus 3 times itself 3 times. So I'm going to write this out as x minus 3 times x minus 3 times x minus 3. And now I have a long and winding road here where I'm first going to FOIL together the first two binomials, and then I'm going to take that result and multiply it times the third one. So I'm going to follow the same pattern that we did before. So I've got x times x gives me x squared. My outer gives me a negative 3x. My inner gives me another negative 3x. And then finally, my last negative 3 times negative 3, I get a plus 9. So I've got that times x minus 3, the remaining x minus 3. And so clearly we have some like terms in the middle here that we can combine. So just in the interest of space, I'm going to combine those into a minus 6x here. And so now, even though it's not FOIL, I don't have a fancy and convenient acronym to describe what's going to happen next. Those principles still apply, where I'm going to take everything from the first set of parentheses and make sure that it multiplies everything in the second set of parentheses. So my diagram here is going to get a little ugly as I draw 6 different lines connecting the pieces from the first set of parentheses to the second, but hopefully you'll follow along and stay with me. So my first here, x squared times x, gives me x cubed. Then I'm going to take that x squared and multiply it times the negative 3, so I've got negative 3x squared. Now I need to do the same thing with the 6x, the negative 6x. Don't want to overlook that negative sign. So it's negative 6x times x gives me negative 6x squared. And then that negative 6x multiplies the negative 3, so that becomes positive 18x. So I now just have to make sure that 9 multiplies everything in the second set of parentheses. So I've got 9 times x gives me 9x. And then finally, 9 times negative 3 gives me negative 27. And so now my last thing to do is to make sure that I combine my like terms. So x cubed stands alone. I've got this negative 3x squared and this negative 6x squared. Those combine to make negative 9x squared. I've got 18x and 9x. Those combine to make 27x. And then finally, the minus 27 at the back end. And so there is our result of cubing out x minus 3 cubed, which is decidedly different than if we had just cubed the individual pieces and written down x cubed minus 27. So we just have to make sure that we remember that this is a FOIL question in principle, and that's the approach that we need to take.